Step 1. Build arrays. So to make an array of 2 times 3, we need 2 rows of 3 columns. And when you add all that together, you get your answer. And remember, it doesn't matter which way around you make your array, you'll always get the same answer. Arrays can be used for any size of calculation. So for 4 times 5, you could have 1 row of 5, 2 rows of 5, 3 rows of 5, and 4 rows of 5. And then that can all be added together using skip counting or any of the other addition strategies that you've been learning. Now remember, it's important to always start your arrays with concrete items like counters or cubes. And then once you're confident building the arrays, you can move on to drawing them using circles or dots or really any other simple shape. And then when you're confident with that, you can move on to drawing a rectangle where the dots would be to help you with your calculation. And arrays can easily be adapted for division. You just build up your array in columns using counters or cubes before going on to draw them, only this time you know the total, and the part that you have to work out is the length of the row. Step 2. Use strategies. Let's look at multiplying strategies first. Repeated addition. Add the same number again and again. So 2 lots of 15 are 30. Add another 15 for 45, and so on, and so on, until you've got your 6 lots of 15. And here is repeated addition using a rectangle to represent the array. Breaking factors into smaller factors. Break down at least one of the factors into smaller factors and then multiply using that. A factor is just a number that multiplies into a bigger number. So factors of 12 are 3 and 4 because 3 times 4 equals 12. This means I can do 4 times 25 3 times. And because 4 times 25 is easy to work out, then adding the total is easy too. And here it is again, using the rectangle array. Friendly numbers. Change a factor to a landmark number, which is usually a multiple of 10, but sometimes 5, and then adjust for the difference at the end. So when I see something like 9 times 15, I'm going to add an extra group of 15 to make it 10 times 15, because 10 times 15 is much more easier to work out. And then I just have to remember to take off my group of 15 from the 150. Here we can see that the vertical column has been made longer, so that it's a friendly number, which then has to be adjusted for to get back to 9. Partial products. Break one factor into 2 numbers that add up to the factor, then multiply each and add the answers. So instead of multiplying by 15, I can multiply by 10 and I can multiply by 5, and then I add those 2 numbers together to get my total. Doubling and halving. Double one factor and then half the other. Repeat until a simple multiplication leads to the answer. So if I double this 16, I then half the other 16. And if 32 times 8 is still too tricky, I can repeat the process, making sure that I half the other number. Eventually, I get to a calculation that I feel is much more manageable. Now let's look at dividing strategies. Repeated subtraction or sharing. Subtracting the divisor from the dividend until you have 0. In this case, the divisor is 2, so we'll keep subtracting 2 until we've got nothing left. the amount of times I subtracted 2 gives me my answer. Partial quotients. Subtract chunks of the quotient, that's the number being divided, with known easier quotients. In this example, I might find the number 56 tricky to divide. However, because I'm dividing by 4, I know that 4 tens are 40, and if I take that from the total, it leaves me 16 left. So knowing 10 fours are 40 and 4 fours are 16, I can work out how many 4s go into 56. This even works with long division. If I know that 10 15s are 150, and I know that 20 15s must then be 300, so I can then work out that 5 15s must be 75, which means I can only take one more 15 off, and I leave myself with 10 left, which tells me the total amount of 15s along with the remainder. Multiplying up. Like partial quotients, except you're starting at 0 and adding up instead. So I can think of this as 15 times what gives me 550. Well, I know that 15 tens are 150, so 15 20s must be double that, and 15 5s must be half of 150. And with a running total so far of 525, I know that I can only add on another 15 before I have a remainder of 10. And I know how many 15s it took to get to 550. Proportional reasoning. This is the reverse of doubling and halving, where you think of the calculation as a fraction, then half it and half it, or third it and third it. Because they're both even numbers, straight away I know that I can halve both parts, which gives me 192 divided by 8, and I can halve both of them again. In this case I'm lucky because I've still got even numbers, so I can now take 96 and divide that by 4, which leaves me with my last half, which is 48 divided by 2, giving me my answer. Step 3. Keep practicing. As with addition and subtraction, the best way to get better at multiplication and division is just to practice. Practice with small numbers, practice with big numbers, try out different strategies, and you will make improvements.